Okay, so this is my data that I've collected in the survey. Okay, the null hypothesis, alternative hypothesis. Okay, for this studies, I wanted to check if the survey matched the national data on exercise frequency. So I set up two hypotheses. The null hypothesis say there is no difference, meaning the people exercise once a week based on national statistic. The alternative hypothesis say my survey might be different from the national value. From my result, 73.69% of my respondents exercise at least once a week, which is very different from the national figure. Because the number is almost the same, it suggests that the survey sample representative of the population. Okay, for task 2, we collected data from 38 respondents. The sample size, which is the number we surveyed, is 38 people. This is the number surveyed that I get from 38 people. From the response, we calculated the mean, which tells us the average value. So this is the formula for sample size. We also calculated the sample mean, which tells us the average value. This is the formula for average value. Average is 78.44, which is the one that I list as cell. Okay. For the samples, the sample standard deviation, we also calculated it, which measure how spread out data is from the mean. Here, the standard deviation is 1.433. A smaller standard deviation would mean the responses are close to average, while the larger value shows that the response will be very more likely. This is the formula standard deviation. For class 3, the population mean is where we are testing against. For task 3, the population mean is where we are testing against. The, for task 3, the population mean is where we are testing against. In other words, the claim is the claim that we want to check. For cynical level, the threshold deciding whether to reject the claim. For example, 0.05 means we are willing to accept 5% chance of making wrong decision if the claim is actually true. Okay, for sample mean, for the test statistic, the formula is sample mean minus population mean divided by sample standard deviation divided by square root sample size. This is the formula. This gives us T0, which shows how far our sample mean is the population mean in terms of standard error. Okay, for p-value, this is the formula. This formula finds the p-value by taking the absolute value of T0 and checking how likely it is to get a value is extreme, multiplied by 2 of the two-tailed test in comparison and decision. Since the p-value is much smaller than significant level, a equal to 0.00. Since the p-value is much smaller than significant level 0.05, therefore we reject the null hypothesis. In conclusion, based on the result of a p-value is much smaller than 0.05, this means I reject the null hypothesis. From a sample of 38 people, the average number of times exercise per week 2 times is significant by the difference between 0.74 times per week. Okay, for task 4, the marginal error is calculated by this formula. Confidence norm, the F30, F4 significant level, F25 is the standard deviation, and F23 is the sample size. But the confidence interval population mean is we take the sample mean minus the marginal error for the marginal error E, and for this one is just plus, same formula but plus.